All right, gang, we're going to talk about one of the better named wireless technologies right now, and that is ZigBee. Okay? A ZigBee wireless network. Now, what is this? Again, it is not a Wi-Fi network. It is not interoperable with an 802.11 Wi-Fi network. In fact, it's an 802.15 network. It's 15.4 rather than 802.15.1, which was Bluetooth, but it is based upon that same standard. And what that means is that it is designed to be a low power, relatively short distance wireless communication tool. But it's a little different than Bluetooth because it's designed to build me a mesh network to enable interoperable communications that looks something more like this, right? Where I've actually got a star or a point to multi-point or a cluster of stars that are configured together. We're going to come back to this in just a second. Let's talk about it as a standard though, okay? So designed to build me a mesh network, lots of redundancy, high reliability. And it was really designed with a goal toward serving an automation-based network, serving an industrial setting or a home automation setting where I have a central console where I can configure through the dispersal of a ZigBee network things like, okay, in a home network, for example, what's the temperature of the water heater? What's the temperature in the house? Air conditioning, heating, all that sort of thing. Maybe making sure that maybe all the devices, maybe certain devices are turned on or off. Make sure all the TVs are off or something like that. I can actually go through maybe and heat up the pool or the jacuzzi right before I get home. All of these done without my having to wire some piece of line between my controller and between the end device, the heater, the air conditioning unit, the whatever module it is that we're trying to manage. In an automation sense, I mean, think of all the things that happen in automation, all the conveyor belts moving and picking things up and putting them down. We may need to change speed, we may need to change flow, we may need to simply report back on how they're doing right now. So, are you overheating? How's your airflow? Things like that. So doing that wirelessly is a thing of beauty. And so rather than an 802.11 wireless network, which has a fair amount of overhead, really, for the small amount of simple instructions or simple data, conveyance that we're trying to find, ZigBee provides a great answer. All right, so it's designed to run at low power. And that's important because a lot of our end devices, I want them to be able to be truly completely autonomous, where I don't even have to plug them in. They're running off of battery power and they can run that way for months or years without my having to touch it. But they're running at a low data rate. All right, they'll save up their data, send it out in a burst, typically is how it's going to do. So not a lot of constant communication. And notice 20 to 250 kilobits per second. That's not a typo, that's kilobits. Now remember, Bluetooth could go up to 24 megabits per second, and this is not that. This is much slower. So again, designed low power for a specific utilization. Now it can be secure. We can wrap that in AES 128-bit encryption keys to ensure that it is not being transmitted in an insecure way. We have secure sessions. It's self-configuring, so it's very easy for these guys to just kind of hook up and say, okay, I'm a part of the ZigBee network here. And we've talked about the application that are in mind. Again, low power, simple installation, literally designed to allow for throwaway kinds of devices based upon this. When we work with a ZigBee network, it is in North America using the 2.4 gigahertz range, so it does have the chance to interoperate in an incompatible way with Wi-Fi. In other words, it can introduce interference in your Wi-Fi network, hurt it, not help it, just like a Bluetooth network can do, and certainly something to consider. Now, when we work with that, the way that a ZigBee network works is kind of similar to a Bluetooth Piconet, in that there will be a network coordinator, a particular device that is an active device. It's a full function device. Not only could it potentially measure things or perform actions, interoperate with the physical world, it's essentially what is responsible for the establishment of the ZigBee network itself, which can then also branch out to other devices, so on and so forth. In order to introduce a less expensive solution, a lower powered solution, we also have reduced function devices. And in many cases, this is exactly what you're going to have out on the periphery, your actual physical devices, the ZigBee component that is hooked into the heater, the automation system, whatever it might be. It is a reduced function device, meaning it can participate in a ZigBee network and convey its information and send its instructions as necessary, but it will never become a network controller. All full function devices have the potential to run the network, to run the ZigBee network, to kind of be the master controller over all of it. A reduced function device can't. It's going to be an edge device participating in the flow. And you'll notice that that means that ZigBee data flow cannot go through it, it can only go to it. So that changes potentially your ZigBee architecture as you're designing this out. All right, so ZigBee networks, remember how they do have a potential to cause interference with a Wi-Fi network, just like Bluetooth can, because they're operating at the 2.4 gigahertz frequency range. Remember that it is essentially an industrial, probably it's edging actually into wireless local area network, but notice it is without an infrastructure beyond itself. So it's not designed necessarily to connect into the wired network per se, but to provide this information to communicate amongst itself.